Welcome to the Liberty software-defined instrument, Liberty Multi-Channel Real-Time Spectrum Analysis. RF test requirements are accelerating. More channels, complex waveforms, tighter tolerances, all demanding true real-time performance. Introducing Liberty, the multi-channel real-time spectrum analysis platform redefining what's possible. Liberty functions as a multi-channel real spectrum analysis platform available in both AXIe and PXIe architectures. Wideband RF downconverters feed high-speed digitizers, up to 16 gigasamples per second in AXIe and 4.8 gigasamples per second in PXIe, providing up to 1 GHz of instantaneous bandwidth per channel. Each channel streams data in parallel to FPGA engines that perform continuous gapless real-time processing. Together, the AXIe and PXIe platforms deliver a scalable, reconfigurable wideband RTSA solution for modern RF environments up to 64 channels. The RTSA interface displays spectrograms, histograms, spectrum views, and time domain data for all active channels. Users can select which channels to view and configure recording and trigger settings directly from the interface. This enables synchronized monitoring and analysis across multiple RF channels. The indicator panel shows capture and analysis parameters, FFT settings, T-min values, windowing, sweep mode, and record status. It provides a single, consolidated view of how the RTSA is configured. T-min is an important metric that reflects the system's ability to detect short-duration signals. For this configuration, the system achieves a T-min of 128 nanoseconds, enabling detection of extremely short pulses. Liberty also decouples capture and analysis parameters, providing more flexibility than traditional RTSAs. This architecture improves sensitivity while maintaining wide capture bandwidth. Users can capture a full 1 GHz bandwidth while analyzing only a portion of it. This improves signal-to-noise ratio by narrowing the analysis span. Each channel can be configured with independent frequencies, spans, and bandwidths. When the analysis bandwidth equals the capture bandwidth, the system noise floor is approximately -82 dBm. This represents the baseline noise floor for 1 GHz real-time analysis. When the analysis bandwidth is reduced to 100 kHz, the noise floor improves to roughly -112 dBm. This 30 dB improvement demonstrates the advantage of decoupled analysis. Parameter control can be independent, partially independent, or locked. In partial mode, all channels share capture settings but can use different analysis spans. This gives users the flexibility to match their mission or test scenario. The RF record panel allows users to set file names, directories, duration, and pre- and post-trigger buffers. A circular buffer stores incoming data until a trigger occurs, enabling precise capture of events of interest. Recordings can be stored as snapshots or streamed directly to RAID. Triggering can be software-based, external, time domain threshold-based, or spectrum-based. Users can trigger recordings from signal amplitude events, external hardware, or spectral changes detected by the FPGA. Frequency mask triggering activates when a signal enters or leaves a defined spectral boundary. Masks can be created or imported, giving users control over how out-of-bounds behavior is detected. Frequency density triggering uses histogram data to detect how often energy appears in specific regions. If activity exceeds user-defined thresholds, the system triggers a recording. This method is effective for intermittent or low-probability signals. In partial independent mode, each channel can use a different trigger type. For example, one channel may use density triggering, another a frequency mask, another a time domain threshold, and another an external trigger. All channels begin recording simultaneously when any trigger condition is met. The spectrogram displays frequency versus time with full control over FFT size, sweep period, overlap, and detector mode. Users can store both raw data and spectrogram frames, enabling detailed offline analysis. Triggering links spectrogram frames to the exact corresponding raw RF data. The histogram provides a probability density view of power versus frequency. Users can adjust observation intervals, smoothing, persistence, and display settings. Smoothing can be disabled when precise probability values are required for triggering. To learn more and schedule a demonstration of Liberty, please visit tevet.com/liberty. Liberty, powered by TEVET and Keysight Technologies.